The built-in sorted function is a good example to demonstrate the use of closures. It takes two arguments, an array of values of a known type, and a closure or a function. It is a method that works on the array and returns true and false. And then the sorted function generates a new array with everything in the right sequence for that sort. So, let's start with an example where I'm using function first. First, I will be using the sorted method with a regular function, and then I will demonstrate how I can use the same approach with closures. First, I create a function called forwards, and with two strings, s1 and s2 as parameters. The function returns a boolean as a result. Inside the function body, it returns the boolean result of the comparison where the condition checks if s1 is greater than s2. So far, the code in the forwards function means that if the value of string s1 is greater than the value of string s2, the value of true is returned. Next, I create an array called letters containing 4 array items, H, E, X, and A, all in uppercase. To sort this array, I can pass the array to the sorted function and store the result in a variable. First, I create a variable called sorted, and then assign to it the letters array with the sorted method applied. I do this by typing letters dot and select the sorted by method from the drop-down option in Xcode. Then, inside the parenthesis, I add the name of my function forwards after the colon symbol. When I run this code, it will first compare if the first item in the array H is greater than the second item in the array E. It will compare the letters with each other and swap them around. It will sort this using its logic, and I will just have to trust it. Let me demonstrate this now by outputting the sorted array using the print function. On a new line, I type print sorted to output the result of the code to my screen. The output, XHEA, is displayed at the bottom of my screen. Notice that the letters are sorted in descending order. Now that I know what can be done, let me do the same with closure, all in a single line of code. To do this, I create another variable called myCollections and assign it the following. First, I once again place the letters array with the sorted by method. Next, after the colon, I insert the code I need to use a closure. First, I type open and close curly brackets. Inside those, I place open and close parenthesis, and inside that, I insert s1 colon string, comma, s2 colon string. Now, outside the parenthesis, I place the code to return a Boolean result. After the keyword bool, I type the word in. Then on the next line, I type return. And finally, s1 less than s2. To determine if my code is working, I run the print function to output the value store in the variable myCollections. Notice that the results are the opposite of my previous result, A, E, H, X. The reason for this is that the comparison operators are different, but the logic is the same as what I demonstrated when using functions. Because the closures pass arguments to the function, Swift can infer the types so it can work out some of these things and simplify them. In this example, I have the original closure, but because Swift can infer types, I don't need to know what S1 and S2 are because I have an array of letters and I know what's in that array. I can further optimize this code by removing all the types. I do this by deleting the colons and strings after S1 and S2, as well as the arrow and Boolean. When I run the code now, it works the same way, and the result displayed at the bottom of my screen is the same as the previous result. I can simplify my code even more. In Swift, it is possible to omit the parameter names in closures. When doing this, you refer to the omitted argument with a dollar symbol followed by the index number of the array. For example, I start with $0, then $1, and keep on adding until all the arguments have been replaced. To demonstrate this, I copy the code on line 12 and replace everything inside the curly braces with $0, $1. Let me just cut and paste this print function under my new code. In order not to get a variable declaration error, I comment out the previous code for myCollection on line 12. Notice that a less than sign has been added between $0 and $1. 0 and 1 can be viewed as indexes of an array. $0 and $1 is called shorthand argument names. If I run the code again, the result should be the same. And that's a brief introduction to closures, how to create them, and a simple example of how to use them. In this video, you learned about closures and how developers can use them to write anonymous code that can be stored in a variable to be executed anywhere in the program. You also learned how closures are useful by providing functionality to sort an array of values.